Hey, good morning. Today we are going to continue here with our function notation by talking about inverse functions. Now, an inverse function, if you think about something that's inverted, okay, it's just kind of switched around. It's flipped around. So an inverse relation maps the output, okay, let's chat about these funky words here again. Output is your y values. Compares those to the original input or x values. We put in the x, we get out the y, okay? Or we substitute in the x, we get out the y, because we've done that before. Now, I won't go real in depth with these 5 concepts because we're going to touch on them as we go through the sections. But the biggest thing we kind of got to keep in mind, whether we're looking at it graphically, we're looking at it in a table, no matter what, we're basically just switching the x and y values around. We're mirroring them to a different way. Because if you look at switch x and y, switch, domain, and range. Okay? You reflect the line, which we'll see when we're doing the graphing here in a little bit. Okay? The inverse is a function if it passes the horizontal line test. We'll chat about that some. And then compositions will be back. So all these ways we can prove a function and it is an inverse of another, 5 different ways. Just a lot of tools in the toolbox. Any of them work though. So first one, we like to start with the easiest one. To find the inverse, you switch the x and the y. If you have them listed like this, okay, literally all you're going to do is you're going to take your x row here, you're going to put all of those in the y column. You're going to take all your y's, you're going to stick them in that, and that's it. Now, what if they're not listed in a chart? What if they're listed instead as coordinate points? And I'm going to do these in different colors so you can kind of see. Because then when I come over here, they're all flipped. The 4 has gone into the x slot. The y is over here. Okay. And you're just looking, the points are just flipped, literally. I mean, 0, 0 can't really change. It's 0, 0. But other than that, we're just taking all of these. So it's just inverting them, okay? Flipping the x and y values around. So if they're points, if they're a table, that's all you do to find the inverse, okay? What about if you get into a situation like 2 or 3? Now, it's a little more complex with this, and here's why. We are going to switch the x and the y. But when you get into this situation, once you switch x and y, we're going to solve for y. Because we still want to have 2 equations that we could graph if we wanted to look at the graphs of these and to see what the inverse is of the other. So we switch x and y and solve for y. And actually, let's do that. So 2 switch x and y. Probably good to put that note here so when I'm using it later, I can actually look at it and go, oh, okay, that's what I actually did there. Because you're like, why'd they switch? Because we're supposed to. So here, okay, if I want to solve for y, whatever's on that side of the equation with y needs to go away. So the first thing, that -4 needs to go away. We need to do an opposite. And again, it's little things here. This is x plus 4, not 4x. I didn't multiply. And then my last step to get y alone is to, opposite of multiply, is to divide. Now when you get here, you are perfectly fine to leave it like this. Or if sometime you're asked to keep them as separate fractions, you can split these up and have 1/2 x plus 4 divided by 2 is 2. Those are equivalent. They're the same thing. They're just written differently. So, something to keep in mind. But either one works. Okay? It'd kind of be the equivalent of somebody coming up and saying, hey, I'll give you a $50, I'll give you 50 cents. It's the same thing, just said a different way. Same thing on number 3. Switch the x and y, and we're solving for y. Now, I'm a fan, in this situation, of getting the y term isolated before I deal with the fraction. Okay? So we're going to minus the 6 over. We got to do the opposite to get it there. And here's what I'm not a fan of. Do not just hit divide by negative 2/3 and leave me this big, huge, ridiculous looking fraction that looks like this. Okay, that is not going to be the way this answer is written anywhere. We don't want to do that. And I don't think a lot of you understand how you would manipulate that back into looking something normal. So here's what we're going to do instead. We're going to get rid of it piece by piece. In other words, we're going to get rid of the fraction part first. The fraction part is divide by 3. So we do the opposite, and we multiply by 3. Now, if you want to, and I would, I'd go ahead and distribute the 3. And all of a sudden, this looks a lot more reasonable. Okay, a lot more of what we're used to. And like we saw before, I am perfectly fine with you leaving it like this, but let's say you're on a site like Quizzes or Delta Math, and you're looking at the answers and none of the answers look like this. Here's where we've got to be able to adjust. We'll adjust around my head here. Take it in pieces. If you do 3 over negative 2, oops, let me try to get that a little less glare. Okay, we don't do the decimals. The likelihood is they're not going to be there. It doesn't simplify anymore. So negative 3/2 x, and then negative 18 divided by negative 2 is 9. Either one of these is mathematically correct, but as we've seen on these sites, they can be touchy. If, and I've told some of you this, I'm going to say it again here, if you sometime, let's say you put this in as your answer, and it says, no, it's wrong, this is the answer, take a picture with your phone, screenshot your screen, and send it to me. I'll give you credit back. Okay, we can make this work. That's the one thing, again, that's a little different about me seeing your paper and being able to say, yep, that's the same thing, versus a computer program doing it, and all I see is grades, okay? So if you had that trouble, let me know, or even type to me what you had for the answer and what they said the answer was, and we can make that work. Just a little effort. Okay, so that's our switch x and y. Part 2. The inverse is a function if the original passes the horizontal line test. Okay, quick question. Oh, as everything moves on me. Let's try this again. Horizontal line. This way or this way? This way. Okay. So what we're going to do is we're going to take whatever graph is here, and we are going to draw a horizontal line somewhere through the middle of it. Okay, it doesn't have to be perfectly in the middle, but here's what we're testing. How many points does my line go through? If it only passes through 1 point, okay, then yes, the inverse would be a function. Now I'm going to show you a little trick here that kind of lets you see this too. Because before we did the vertical line test to see if something was a function, if you take any of these graphs and turn them 90 degrees, okay, that's what the inverse of the function would look like. And it would pass it anyway because it passes the vertical line test. So just something to kind of keep in mind to reference from what we've learned before. Now, 7 7's going to be a little different of a circumstance. 7, holy moly, 1, 2, 3, 4, 5, 6, 7. Okay. If it's more than 1 point that your horizontal line goes through, not an inverse function. Because actually, if you turn this one sideways, it's not a function to begin with. So the inverse can't be a function if the regular one isn't. And then finally, you probably can tell in this last one, and again, just somewhere near the middle. Here's my 1. So let's just say there happened to be a question, maybe on a slide in the future, that says, hey, is the inverse of this a function? Yes. Why? Make sure you can explain with, it only passes through 1 point, so it passes the horizontal line test. We need language like horizontal line test and 1 point, not just, yeah, it is. Okay, why? You have to be able to explain stuff. Okay, that's true in a lot of ways during life, but especially here. All right. And as always, maybe you watched during the live, maybe you're watching this again just for a piece and you're still having a question, reach out to me. I'm perfectly willing to help. Okay, more practice finding inverses. Remember, okay, reminder. If I remember how to spell reminder. Anything of x, f of x, g of x, h of x is the same thing as saying y equals. So what I like to do is I like to go in here and change these to y's. And now it's just like what we were doing on the front. Switch x and y. And we're solving now for y. So instead of minusing 2, I'm adding 2. And on this first one, we'll show it. We always like to see things. And little things like this is x plus 2, not 2x. And again, your answers, you have options. Since we're multiplying by 5, we're going to divide by 5 to both halves. This is a perfectly acceptable answer. But again, if you don't see that as an answer on something, you may have to separate these. 1x over 5, or 1/5 x, plus 2/5, since it doesn't simplify any further. Equivalent answers, just a little different. And so one more to look at. Switch x and y. Now here I got to be careful. I want to solve for y, but notice the y is in the denominator. The y is the fraction right now. So how in the daylights am I going to fix that? The same way I would as if this was y over 4. What's in the denominator? Y. What do I have to multiply by to get it out of there? Y. I know, this is weird. Yx equals 4. But y is not solved for yet. I need y alone. So how do I get it alone? What am I doing to it? I'm multiplying it by x. How do I undo multiply? And there's no other fancy way to write this. I can't write it as 4x. I can't write it as 1/4 x because the 4 is up top. So that would be my answer. You're like, well, wait a minute though, Hardy. Like, that didn't change at all. Occasionally, you will get a function whose inverse is the exact same thing. They like reflect right on top of each other. That'll happen. So don't freak out if that happens. It does happen occasionally. Okay, explanation time. Gee, this might not come up on anything in the future. Explain how to use the horizontal line test to determine if an inverse relation is an inverse function. Okay. Well, first we got to draw a horizontal line if we're going to take the test. Okay, so we're going to draw a horizontal line through the original relation. In other words, through the original expression, the original equation. Okay, the original graph, even if you wanted to put it that way. Okay, that's perfectly fine. If it crosses one point, it's the inverse. Okay, you don't have to get fancy here. Crosses more than one point means it's not the inverse, okay, of that original function. That's it. Horizontal line. 1 point inverse. More than 1 point? Nope. Okay. Explain the steps for finding an equation for an inverse function. Okay, we've just been doing this a lot, like up in number 10 and all that stuff. We kind of wrote it on the front. Switch x and y. Solve for y. Doesn't have to be complicated. Doesn't have to be a 6-step thing. Just switch x and y, solve for y. There's my inverse, and we're good. Okay? Your job again here, you've got several things, and you're going to keep seeing this if you're new to the class. Every single time we're getting into these, we have some paper and pencil part, and if you just have to sketch a few things on a piece of paper because you couldn't get a packet, you don't have a printer, that's okay. But again, practice each of the things. Now, one thing we didn't do on here, which I'm going to do with you right now because I just noticed this. Okay, this is over on the practice on the next page. So find the inverse, we switch x and y, we solve for y. But down at the bottom, find the inverse of the function, then graph the function and its inverse. So let's see, which one of these do I want to do? I see it's a little more screwy on number 6, so I'm going to do number 6 with you. Okay, so this is our original function. Graph not set up real well for this. I apologize for that, but we'll work at this. So we remember f of x is y equals. So to find the inverse, which I'm going to do completely in red so they stay separate here, switch x and y, solve for y. At 12. And again, if you're doing one of these practices sometime, the keys are right there in the Google Classroom as well. So if you want to check something and it's not working, shoot me a picture. Or somehow find a way to write what you did and send it my way. Divide by 4, divide by 4. Now, when I'm going to graph it, I'm not a fan of leaving it as a fraction. I want to see it in slope-intercept form. So I got 1/4 x, not 4x, the one's on top, and 12 divided by 4 is 3. Okay, there's my inverse. So now I'm going to graph both of these. Positive 3, and then again, slope. Rise over run. Up 1, right 4. Up 1, 1, 2, 3, 4. And if I run out of room, I do the opposites of both. So instead of up and right, I do down and left. Down 1, 1, 2, 3, 4. I want at least 3 dots, so if I screw up something, I'm going to see it. Now, my other one, this is going to be a little more complicated. Because what happened? Yeah, I didn't give you a big enough graph. So what we're going to do here is we're going to get creative. This is going back to when we were talking about if a baby's crying, how are we going to make this work? Because we can't just leave the baby crying. So we're going to get us some lines drawn in here. Some of the greatest things ever have been discovered when people have had things go wrong, and then there's something like, oh, well, I got to make an adjustment here. So let's see, 6, 7, 8, 9, 10, 11, 12. 7, 8, 9, 10, 11, 12. Okay. So there's my y-intercept. My slope is 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Because here's where I can also explain, back when we were doing the sheet, doing the actual lesson, it had mentioned, okay, on number 3, to graph the inverse, you reflect the original graph of the line y equals x. Let me show you where that line y equals x is. Y equals x is just the place where x and y values are equal. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. And so if I were to take this graph and fold it along that dotted line, y equals x, these two lines would be on top of each other. Like those 2 points are, these 2 points would be on top of each other on the line, and these two. And if this went further, these 2 would, and so on. So it's just a visual way for me to be able to see the inverse. Just like this is algebraically the way I can see the inverse. So we're just graphing. We're just using the calculator, okay? You could use the calculator too and just plot points from it. So if I went that route, now if you've got it already, you can turn me off at this point. But for those of you that are still like, wait, how does all this work again? Let's see here, 1/4, because we always put fractions in parentheses on the calculator, x plus 3. If I look at, oops, window issue. See, hopefully you don't have the window issue like I do here. Somehow my window got messed up. All right, let's try this again. So I'll end up seeing that same graph that I did here. And so what I'm going to do here is I want you to see, I'm going to put one more part in. I'm going to put the line in y equals x. Okay, that third line that I talked about. And you'll notice it like cuts it in half. I'm seeing a mirror image on 2 sides of that black line that's coming through. And if I look at my chart, I'm not going to be able to see as well with this. Yeah, I'm not going to be able to see that as well. But I can see the reflection. Okay? But as usual, if you run into questions on things, as you're doing the practice on here, you're doing the practice on Delta Math or quizzes, let me know. And if I have to, I can make little mini videos for you there too. Have a fantastic rest of your day.